The objective of this lesson is to learn how to write set statements and to determine whether two set statements are equal to each other. But before we do that, let's review some basic set operations. Let's let A represent the set of all actresses, B represent the set of all ballerinas, where the universal set U is the set of all women. Well, in this first diagram, we see that regions 1, 2, and 3 are shaded in. So that would represent all the women that are actresses or ballerinas or both. The way we would write that is A union B. In the second diagram, we see that just region 2 is shaded in. That would represent all the women that are both actresses and ballerinas. The way we would write that down is A intersect B. And then in this last diagram, we see that just the region outside of A is shaded in. This would represent all the women that are not actresses. And the way we would write it down is A complement. The prime symbol denotes complement. Well, using just these three set operations, we can write set statements that represent other regions in the Venn diagram. Let's take a look below here. In our first diagram, we see that just region 1 is shaded in. What does this region represent? Well, it represents all the actresses that are not ballerinas. So the way we would write that down is set A intersected with the complement of B. These are the women that are actresses but not ballerinas. What about in the second diagram? We see that only region 3 is shaded in. This would represent all the ballerinas that are not actresses. So the way that we would write this down is B intersected with A complement. These are the women that are ballerinas but are not actresses. What about this last diagram? We see that just region 4 is shaded in. Well, region 4 consists of the women that are neither actresses nor ballerinas. So one way to write that down would be A complement intersected with B complement. These are the women that are not actresses and they're not ballerinas. Well, looking at these three set statements, we can clearly see that they're not equal to each other because they all represent different regions in the Venn diagram. But sometimes we are interested in writing down set statements that are equal to each other. And if we think back to algebra, suppose we had something like the opposite of A plus B. How could we rewrite that in a different way? Well, we might distribute the negative and write this as the opposite of A plus the opposite of B. So suppose we had something similar, but this time a set statement, where we have the complement of A union B. The complement would be similar to the negation symbol, and the union would be similar to the plus symbol. While using inductive reasoning, we might guess that this would be equal to the complement of A, and then union the complement of B. We're taking, in essence, the opposite of each of the two sets, and then we're keeping the operation inside the same. Here we had plus, we left it a plus. Here we have union, we're leaving it union. We want to know, are these two set statements equal to each other? So we'll put a question mark here. We don't really know. We're just wondering, are these two set statements equal to each other? Well, let's test it out with this particular example. Let's let the universal set be the counting numbers from 1 to 6. A will be the prime numbers from 1 to 6, and B will be the factors of 6. Let's first of all figure out the left-hand side. First of all, we'll find A union B. So we'll take everything in A and put it together with everything in B. We have a 1, we have a 2, 3, 5, and 6. So A union B is the set containing 1, 2, 3, 5, and 6. What is the complement? Well, that will be everything in the universal set that's not in the union. Well, the union contains 5 elements. The universal set contains 6, and we see that the only element that we haven't written down is the number 4. So the complement of A union B is the set containing the number 4. What about A complement union B complement? Let's take it one step at a time. First of all, we'll find A complement. So we take 2, 3, and 5 and cross them off of the universal set, and that leaves us with 1, 4, and 6. For B complement, we take away 1, 2, 3, and 6. That leaves us with just 4 and 5. And then we find the union. What is A complement union B complement? Well, we take everything from A complement together with everything from B complement, and we get 1, 4, 5, and 6. Well, comparing our results, we see that the two sets contain different elements. Therefore, our conclusion is that these two sets are not equal to each other. So what set statement is the complement of A union B equal to? Well, let's take a look at this picture right here. Notice that A union B is not shaded in. What is shaded in is the region outside of that. So this region 4 represents the complement of A union B. But where else have we seen this? Yeah, right over here. Region 4 can also be written as the complement of A intersected with B complement. So because both of these statements end up with the same shaded region, we know that the complement of A union B is A complement intersected with B complement. If we think of this in terms of actresses and ballerinas, it's saying that if a woman is not an actress or a ballerina, then we know that that woman is not an actress and she is not a ballerina. Well, let's take a look back to our specific example and see if it's consistent with our findings. We had already found A complement and B complement. What is the intersection? Well, we see that both A complement and B complement contain the element 4, and that matches what we have over here on the left, the set containing the number 4. So our specific example is consistent with our general result. In this example, we saw how to find the complement of the union of two sets. So that naturally leads us to ask the question, how would you find the complement of the intersection of two sets? Well, we've got a picture of it over here on the left. The intersection of A and B is region 2, but we've shaded in everything outside of that. Well, coming up with an equal statement isn't going to be quite as easy as before because we don't see the same Venn diagram over here on the left. But we might use inductive reasoning. In order to find the complement of the union, we took the complement of each thing inside. The complement of A, the complement of union, which was intersection, and the complement of B. So let's try that here. What if we took the complement of A, and then we might guess that the complement of intersection would be union, and then B complement. Are these two set statements equal to each other? Well, in order to answer that question, we can make use of Venn diagrams. Okay, first of all, what does A complement look like? Well, we need to shade in everything that's outside of A. A consists of regions 1 and 2, so A complement will consist of regions 3 and regions 4. What about B complement? Well, B consists of regions 2 and 3, so B complement will consist of regions 1 and 4. Well, now we need to form the union. So for A prime, we shaded in regions 3 and 4. For B prime, we shaded in region 1 and region 4. So what did we get all together? We got regions 1, 3, and 4, which matches what we had over here, regions 1, 3, and 4. So yes, these two statements are equal. Now it just so happens that these two statements have a special name. These two statements are known by De Morgan's laws. Well, I hope you found this lesson useful. In the next lesson, we'll look at set statements where we have 3 sets instead of 2.